IBM WebSphere MQ. MQ stands for message queuing or messaging and queuing. It is framework. Messaging is the mechanism to define data as message to exchange over the network. Queuing is the mechanism to hold data as messages in MQ server until processed by the remote service. IBM WebSphere MQ built on Java. It is platform independent. It supports 80 plus platforms. It is an IBM middleware message transport product. It enables communication between distributed applications over the network. It is an integration engine. It integrates distributed applications irrespective of the platform, programming language, and protocol by providing an interface MQ API. Look at here. Here we are having two distributed systems. One is Windows and other one is Linux. This is my Windows host and this is my Linux host. On these two distributed systems, applications are distributed. An application hosted on name business service on Windows host. An application hosted on Linux on name business operation. Business service might develop in C language or in C++ or in Java or in .NET. Business operation might develop in C language or in C++ or in Java or in .NET. In between distributed applications, to enable reliable communication, we have to integrate them over the network. To integrate, we configure IBM WebSphere MQ server. It provides common MQ API irrespective of the programming language. It is an interface here. Developers need to know implementation of MQ API. Then programs can connect IBM MQ server. They can perform put and get operation. Look at here. Now my business service wants to exchange some data with business operation. Now my business service defines its data as message. Message is nothing but collection of data. MQ message has two parts. They are MQMD header and the payload. Payload is nothing but message body. In message body, application defines actual business data. In message body, application can define XML data, text data, binary data, anything. After defining message, application connects IBM MQ server. It puts message on queue. Queue is an object. It is file and data structure. It holds messages. Put is nothing but right here. Application delivered message to MQ server. The MQ server queue is available to hold it. If other end application available on online, it connects IBM MQ server. It gets message from queue. Get is nothing but read. When an application gets message from queue, the message no more. IBM MQ server supports once and only once delivery and a guaranteed delivery. Remember, an MQ server major operations are put and get. An application puts data, an application gets data. It is just like passbook here. IBM MQ server, just like passbook. If you see our passbook, we can see only transactions like credit and debit. If we deposit, they credit on our account. If we withdraw, they debit on our account, right? Yeah. Similarly, here what happens, an application deposits data at MQ server, other application draws the data from MQ server. When an application draws the data from MQ server, the data no more. See, on our account, we can withdraw our money once and only once, right? We cannot withdraw money multiple times. That means, for suppose you deposit 10,000 on your account. That 10,000 you can withdraw once and only once. You cannot withdraw multiple 10,000s, right? Yes. Yeah. So here, MQ server just like passbook. An application writes, an application reads. When an application reads, the data no more. Okay. Right. Just look at here. Very easy to understand. IBM WebSphere MQ, known as store and forward mechanism with assured delivery. Business service sending its data as messages to MQ server. In MQ server, queue available to hold. When other end application requests the data from MQ server, forwards from queue. When an application gets data from MQ server, the data no more, right?
Yes.
Sometimes I say data, sometimes I say as message. Okay, don't get confusion. Yes, Nikki?
Yes.
Have any confusion?
No.
Right.
Madhu, this message and data, you are using only terminology changes, but the meaning is same, right?
Yeah.
Okay.
Sometimes I say data, sometimes I say as message. Okay.
Yeah.
As you know, MQ message has two parts, MQMD header and message body. MQMD stands for MQ message descriptor. The header describes the message. The header contains control data. Control data is nothing but the header contains message ID, message expiry, message priority, message persistence type, message type, and information about sender application. That all metadata MQMD header contains. Message body contains actual data. Application can define any data in message body. XML data, application can define. Text data, it can define. Binary data, anything. An application creates message. MQ server does not create message. It does not define any data on message body. Just it can hold and it can forward. Okay. This is simple MQ message. Here you can find message descriptor here to here. These are all the fields in MQMD header. On all these fields, application only defines the values. MQ server does not define. At last, you can see the message body. In message body, available data is HI, high. It is text data. Here, application can define any type of data. Okay, whatever the data application wishes to exchange with the remote application, the data application defines in message body. And it connects IBM MQ server, it opens to, it puts. Other end application gets it. If you compare IBM MQ server with the DB engine, it is easy to understand, Prasad. In DB engine, we define tables to hold data as records permanently. Whereas in MQ server, we create queues to hold data as messages until processed by the remote service. Okay. See here, an application sending messages to Q1 and on Q2. 3 messages available in Q1, 3 messages available in Q2. In between IBM MQ server and DB engine, an application hosted, it wants to get data from MQ server and it wants to insert the data into the database. What it can does now, it opens connection on IBM MQ server and it opens connection on DB engine. It starts transaction with two-phase commit. Then it's get data from MQ server, it inserts the data into the database. See here, data available as messages, here data available as records. Here queue holds messages. In DB engine, tables holds holds data, right?
Correct. Madhu, I have basic doubt. This MQ directly, you mean to say directly interacts with the table and updates the data, or it is through the application which takes care of that?
Directly, IBM MQ server also can update the data into the database. For that, we have to configure the drivers to communicate with the database.
Okay.
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 In MQ series, we are having configuration file. In the configuration file, we define information about the database, password, login username, password, and respective driver's path, everything. Okay. It can update data directly to the database by opening the connection.
Okay, it doesn't require any middle application for that, right?
Yes, yes. If required,
Okay.
you can host. Otherwise, you can directly update the data to the database.
Okay, okay.
Over the IBM MQ server, between applications, we can enable one-way communication. We can enable two-way communication. We can enable time-independent communication. That means it supports synchronous communication and asynchronous communication. No constraints on application structure. Between applications, you can enable the communication. It may be one-to-one, one-to-many, many-to-one, many-to-many. Okay. IBM MQ server is able to support it. What IBM says about MQ, once and only once delivery and a guaranteed delivery, right?
Yeah.
I repeat all the statements together. Please concentrate to listen. IBM WebSphere MQ built on Java. It is platform independent. It supports 80 plus platforms. It is an IBM middleware message transport product. It enables communication between distributed applications over the network. It is an integration engine. It integrates distributed applications irrespective of the platform, programming language, and protocol by providing an interface, MQ API. It is also known as store and forward mechanism with issue delivery. An MQ server major operations are put and get only. An application puts, an application gets. IBM WebSphere MQ can route the data. It cannot transform the data. It cannot perform any operation on message. Whatever the message application puts, that message MQ server holds. If anyone requests, it forwards. That's it. If we compare IBM MQ server with the DB engine, it is easy to understand, right? In DB engine, we define tables to hold data as records permanently. Whereas in MQ server, we define queues to hold data as messages until processed by the remote application. Over the IBM MQ server, we can enable synchronous communication, asynchronous communication between distributed applications. One-way communication we can enable, two-way communication we can enable. No constraints and application structure. One-to-one it supports, one-to-many it supports, many-to-one it supports, many-to-many also it supports. Okay. Finally, what IBM says about MQ: once and only once delivery and a guaranteed delivery. As you know, message is collection of data. MQ message has two parts: MQMD header and payload. Application defines always data as messages. It connects IBM MQ server, it quotes. Other application connects IBM MQ server, gets it. Java is nothing but an object, right? Yes,
Yeah.
please, Nikish. Do you know Java?
Yes, I'm here.
Do you know Java?
No.
Yes, you know Java is nothing but an object, right?
Uh-huh.
WebSphere MQ built on Java, so that here we create everything as an object. Here objects are predefined. MQ predefined objects are 7. How many?
7.
7. They are queue manager, queue, channel, listener, process, name list, and service. These are all MQ predefined objects. We create objects on unique names. To define names to objects, we need char set, right? To define names to MQ objects, MQ series allow char set is A to Z capital, A to Z small, 0 to 9 digits. Allowed special characters are dot, slash, mod, underscore. This is the only char set allowed by IBM WebSphere MQ to define names to MQ objects. There is a limitation about the length. Object name length can be less than or equal to 48 characters except channel name. Channel name can have less than or equal to 20 characters. To administrate MQ predefined objects, MQ provided predefined commands. MQ predefined commands broadly divided into 3 types. They are control commands, MQSC commands, and the PCF commands. Here MQSC stands for MQ script commands. PCF stands for programmable command format command. As a WMQ system admin, we always work with control and MQSC commands. We don't work with PCF commands, Nikki.
Yes.
We don't work with PCF commands. We always work with control and MQSC commands. Control commands are just 20 to 25 available. MQSC commands are only 50.
Okay.
Control commands we execute at OS level. MQSC commands we execute at MQ server level. What is MQ server level? What is OS level? Later I explain, don't worry.
Okay.
What is mean by administration? Create objects, delete objects, modify object definition, start service, stop service. These are all comes under administration, right?
Yeah.
We administrate MQ predefined objects with the help of predefined commands. Okay. Using control commands, MQSC commands, we create MQ predefined objects, we delete, we modify, we start some services, we stop some services. Okay. As you know, hardware, on top of it, operating system. For suppose on this hardware unit, I install Windows. So this platform known as Windows platform. Hardware, operating system, for suppose it is Windows. On this Windows host, we install Windows MQ. If it is Linux, we install Linux MQ. On Windows, IBM WebSphere MQ runs as a service. I install IBM MQ on this Windows host. Now it is running as a service. On Windows, everything will run as a service, right? On top of this, we host MQ objects. Are you clear here? Right. Nikki, in these 7 predefined objects, Queue Manager is an initial object. It is first and foremost object in MQ series. Unless we create Queue Manager, we cannot create MQ predefined objects like queue, channel, listener, process, name list, and service. Queue Manager is subsystem. It controls and holds all the MQ predefined objects. Queue Manager itself, MQ server and MQ engine. Look at here. Very first, I create Queue Manager. Very first, I define Queue Manager. In Queue Manager control, I create queue or queues, channel, listener, process, name list, and service, Nikki.
Okay.
If you don't create Queue Manager, you cannot create.
Queues or channels, any other object.
Right. Channel, listener, process, name list, and service. You know Java, right?
Yes. What do you mean by name list? What kind of name list are you talking about?
If I introduce object name list, that is the day end of the training. Okay.
Okay. Okay.
I cannot introduce now.
Okay.
If you are
Okay.
aware of a little bit, then I can introduce it.
Okay.
Name list object holds list of cluster names. It resolves cluster name conflict to add an object to multiple clusters.
Okay.
Without name list object, we cannot add an object to multiple clusters. We can share an object in only one cluster. If you want to share an object in multiple clusters, which object help you take? Name list object, right?
Yes.
But all I explain you, don't worry. Huh?
Okay.
See here, if an application wants to put message on queue, or if an application wants to get message from queue, it has to make the connection on Queue Manager, right? Then
Yes.
only it can access. Application makes connection on Queue Manager. It opens queue. Queue is a file, madam. To write data, we must open the file, right? To read data, we must open the file, right? Your
Yes.
application Queue Manager, it opens respective file. In
Okay.
MQ perspective, we call it as queue.
Mm-hmm.
Perform either put or get. After performing respective operation on queue, application close the queue and it disconnects from MQ server. Here queue manager is single point of contact to all the applications to access MQ queues to perform put and get operations, right? Application connects queue manager, it opens queue, it performs either put or get, it performs either put or get, it closes the queue, it disconnects from queue manager. In this sequence only, all the applications will execute operations on MQ server. Okay.
Okay.
Prasad,
Yeah.
without class, can I write Java program?
No, it's not possible.
In class, we define all the methods, static variables, everything, right?
Correct. Yeah.
So class is going to isolate all the methods, variables, all right?
Yeah.
So here queue manager like class. If you create queue manager, then only you can define rest of the objects.
Okay.
Queue manager holds all the MQ predefined objects and it controls. Okay.
It's a container kind of thing, right?
Yeah, just consider it as container. Your wish. Yes, Nikki and Prasad, are you clear?
Yes.
Yeah. Yeah.
IBM WebSphere MQ provides an interface MQ API, right? With the help of that interface, programs can define data as messages. They can connect IBM MQ server, they can put and they can get. How developers are going to implement this MQ API, now I will show you. Then you will get clear idea. We don't define any program. We are administrators, madam. We administrate objects only. Yes, Prasad, could you please read out this statement?
Sample C program that asynchronously puts messages to a message queue.
Yes.
Example
This
using
is C program. This is C program.
Okay.
IBM WebSphere MQ provides MQ API to C programming language as header file. Can you see this header file?
Yeah.
Includes for MQI, MQ interface. The developer keeps that header file in library, includes that header file in a program, he starts implementation of that MQI. So very first statement, what it is?
Connect to queue manager.
Program must connect the queue manager. To connect the queue manager, what is the function or what is the method program executes?
MQ connection.
Con.
MQ con. In C perspective, we say it as function. In Java perspective, we say it as method. In our MQ perspective, we say it as MQI call. What it is? MQI call. Application performs operations on MQ server with the help of MQI calls. They are available in interface. They are going to implement all the calls. Okay. After connecting the queue manager, application must open the queue, right?
Yeah.
Open target message queue to put or to get. What is the function? Program executes MQ open. It creates message. After that, to put message on queue, what is the function? Program executes MQ put. After performing either put or get, application must close the queue, right? To close the queue, program executes MQ close. If program wants to disconnect from queue manager, program executes MQ disk. See, this implementation all done by the programmer. We don't implement. Okay, we create queue manager. We create required number of queues in queue manager control. We grant access to application user IDs to open queues to perform put and get operations. Okay, see here, connect queue manager, open the queue, perform either put or get, close the queue, disconnect from queue manager, right?
Yeah.
These are all MQI calls. They are available in interface. Developers are going to implement that API.
Okay.
Now the current program. Now the current program is capable to define its data as MQ message, and it can connect IBM MQ server. It can put messages. If the code is related to the get, it can get the messages, right?
Yeah.
Yes, Nikki, any confusion?
No.
Now I show you sample Java program. Java is OOPS language, right? So IBM WebSphere MQ provides MQ API as jar file. Developer keeps that jar in a lib directory and in class path is going to import the packages, MQ API packages. In the main method, very first statement, what it is?
Create a connection to the queue manager.
Yes, program must make the connection on queue manager. After that, it must open the queue, right? See, specify the queue that we wish to open. Program selects queue, it opens it. After opening the queue, what program can does? It creates message. Who creates message? Application. Remember, owner of the message is an application. The whole message defined by the program. IBM MQ server does not create. After defining the message, to put message on queue, the Java program, this is OOPS language, right? So the method is queue.put. It is equal to MQ put, madam. If application wants to get the message, queue.get. It is equal to MQ get. Close the queue. Queue.close. After performing either put or get, application must close the queue. If application wants to disconnect from queue manager disconnect, right?
Yes.
So this is how developers are going to implement MQ API. They define respective data as messages they put and they can get on MQ server. Okay. As administrator, you administrate 7 objects with the help of 43 different commands. See, in MQ series, 7 objects available. How many objects? 7 objects. 40 commands. Major operations are put and get. Data comes to MQ server as message. In MQ server, queue is available to hold. Yes, this is outline here. Is it difficult to learn?
No.
I don't think so.
Here commands are normal English words, madam. MQSC commands are only 15, right? They are alter, clear, display, define, delete, end, start, stop, suspend, resume, refresh, reset, resolve, and one more newly introduced set. So total 15. So these 15 only we have.
Okay.
These are all MQSC commands. What are they? MQSC commands. To take the control commands, they are 20 to 25. They are also very easy to remember. So I introduce. With the help of control commands, madam, we control MQ services. With the help of MQSC commands, we administrate MQ objects like create, delete, modify. Okay, these are all operations done by the MQSC commands. To start and stop some services, we take the help of control commands. Okay.
Okay.
Right. This is the discussion.